Hello students, as we know the chapter number 9, some applications of trigonometry completed from our textbook. Now in this session we discuss some extra sums regarding the chapter number 9. Questions are there. First, the height of tower is 10 meter. Find the length of shadow when sun's elevation is 45 degree. Whenever the sun, we need to see the sun, we raise our hand so that the angle of elevation of the sun becomes at our eye object is upside the horizontal line. First, we need to draw a figure. The height of tower is 10 meter. First, draw a tower which is in 10 meter height. AB represent 10 meter tower vertical to the ground. Find the length of shadow. AB is a 10 meter tall tower. The shadow of tower on a ground level, suppose represented by BC, it is a shadow of tower. Need to join AC. From C, sun's altitudes is line of sight CA and CB is the horizontal angle between them, which is 45 degree. Keep in mind the side opposite to angle 45 and side adjacent to angle 45 both are equal. Find the length of shadow. BC is equals to length of shadow is equals to question mark. In right triangle ABC, use 1045. 1045 is equals to its opposite AB upon adjacent BC. 1045 is equals to 1, AB 10, BC remains as it is. That's why BC is equals to 10. What is BC? BC is the length of shadow when sun's altitude means sun's elevation is 45 degree. Hence, length of shadow is 10, unit is meter. Same way for the second number, both are somewhat equal. When sun's elevation is 30 degree, length of shadow of 10 meter tall tree is equals to question mark. Here the 10 meter tall tree is given, represented by PQ is tree 10 meter. Vertical to the ground, sun's altitude becomes at this point, suppose at R to P. Line of sight RQ is a horizontal and this angle is 30 degree. We need to find length of shadow of 10 meter tall tree. PQ is a tree, then QR is a shadow of tree. Shadow of tree. It's an objective type question. So here I am not writing the description about the figure. Okay. Try yourself to write the description of figure. QR is equals to length of shadow of tree, and we need to find it, so that question mark it. In right triangle PQR, tan 30 is equals to its opposite PQ upon adjacent QR, where tan 30, value of tan 30 obtained from the table, which is 1 upon root 3. PQ is 10 and QR remains as it is. That's why QR is equals to 10 root 3, unit is meter. Okay. Hence, length of shadow of tree is 10 root 3 meter. Completed. Third number. A ladder leaning on a wall makes an angle of 45 degree with ground. A ladder leaning on a wall and makes an angle 45 with the ground. Height of wall is 5 meter. Find the length of ladder. First draw a wall. Wall AB is vertical to the ground. Height of wall is 5 meter. It's vertical to the ground. A ladder leaning on a wall makes an angle of 45 degree with the ground. It's a ground. Suppose AC represents ladder making angle 45 degree with the ground. Find the length of ladder. We need to find AC. Length of ladder is equals to question mark. To find the length of ladder, use trigonometry ratio. Ladder is look like hypotenuse, so that opposite we know AB and AC is the hypotenuse. Opposite and hypotenuse is applicable for sine and cosec. We apply sine here. In right triangle ABC, sine 45 is equals to opposite AB upon hypotenuse AC. Sine 45 from the table 1 upon root 2, AB 5, AC remains as it is. Now make AC as a subject. AC is equals to 5 root 2 meter. But what is AC? AC is length of ladder. Therefore, length of ladder is 5 root 2 meter. Let's see the next fourth number. Ratio of height of tower and length of shadow is root 3 gem 1. Find sun's altitude. Sun's altitude means the angle made by line of sight with the ground level. First draw a figure. Suppose here A, B, C. Where is the sun's altitude? B is the 90 degree. At A, position of sun is there, so that angle of elevation of suns made at C means sun's altitude is at C, and we need to find it. AB is equals to tower and BC is shadow. Length of tower or height, sorry, not length, height. Height of tower and BC is equals to length of shadow. We need to find sun's altitude. For that, given the ratio of height of tower AB upon length of shadow. Length of shadow means BC is equals to root 3 gem 1. AB is opposite side and BC is the adjacent side, so that apply tan here. In right triangle ABC, use tan C is equals to opposite AB upon adjacent BC, where the tan C remains as it is. AB upon BC is equals to root 3 upon 1. Tan C is equals to root 3 upon 1. That's why value of tan C is root 3 when the value of angle is 60 degree. Compare the angle C is equals to 60 degree. Sun's altitude is 60 degree. Hence, sun's altitude is 60 degree. Here extra 4 are completed. Now we discuss next. Let's see the next fifth number. Fifth number is a sum of 3 or 4 marks. Related sum is not given in our textbook. The height of flagstaff placed on the top of a building is h meter high. The building is h meter high. The height of flagstaff placed on a top of building is h. Watching from a point on the ground, the angle of elevation of the base and top of the flagstaff are observed to be alpha and beta respectively. Prove that the height of the building is h tan alpha upon tan beta minus tan alpha. For that we need to draw first the figure. Keep in mind, whenever you draw your figure, use a scale and pencil. Height of flagstaff placed on a top of building, so that first draw a building. Building is vertical to the ground. AB represent building. It's a building. Flagstaff is placed on the top of building. Top is A. At this point, the flagstaff is placed. Suppose flagstaff is AC. It's a flagstaff. And the height of flagstaff, which is h. Watching from a point on the ground. Suppose the point C on a ground D. Watching from the point D on a ground, the angle of elevation of base and top of flagstaff. A is the base of flagstaff and C is the top of flagstaff are found to be alpha and beta, so that C to D, D to A, line of sight, and DB is the horizontal. Angle ADB is the angle of elevation of bottom of flagstaff, and bottom is the base. For the base, angle of elevation is found to be alpha, and from same point D to C is line of sight and DB is horizontal. Angle CDB is the angle of elevation for top of flagstaff, but for the top of flagstaff are observed angle of elevation is beta, so that it is beta. Building is vertical to the ground level. First describe the figure. In the figure, AB and AC are building and flagstaff, where A is base of flagstaff, A is base and C is top of flagstaff. AC is equals to height of flagstaff and AB is equals to, we need to prove that AB is equals to height of building. We need to prove that height of building is h tan alpha upon tan beta minus tan alpha. So that assume AB as a x, AB as a x, so that BC is equals to AB plus AC, where AB is a x plus h, which is BC. Okay. Now two angles of elevations are there. First write for alpha. Angle ADB is equals to alpha is the angle of elevation forward angle of elevation of base of flagstaff from point D on ground. Same way, angle CDB is equals to beta is the angle of elevation of top of flagstaff from point D on the ground. Completed. First apply tan in right triangle ABD. In right triangle ABD, use tan alpha is equals to its opposite AB upon adjacent BD, where tan alpha remains as it is, AB is equals to X and BD remains as it is. Now we don't need value of BD, but by making subject as a BD, we get a value of BD in form of X and tan alpha. We want answer in form of tan, and X is the height of building. It is our result number 1. Now apply trigonometry ratio tan in right triangle CBD. In right triangle CBD, use tan beta is equals to its opposite BC upon adjacent BD. Tan beta remains as it is, where BC is equals to X plus H and BD is equals to X upon tan alpha. Denominator go to the numerator, and X, suppose one time X remains as it is, tan beta is equals to tan alpha into bracket X plus H upon X. Now multiply X with tan beta and tan alpha to the bracket. X tan beta is equals to X tan alpha plus H tan alpha. We make X as a subject because we need to prove that the height of building is X is H tan alpha upon tan beta minus tan alpha. So that shift X tan alpha, the right hand side to the left hand side. X tan beta minus X tan alpha is equals to H tan alpha. That's why X is common, remaining into bracket tan beta minus tan alpha is equals to H tan alpha. Making X as a subject, X is equals to H tan alpha upon tan beta minus tan alpha. Hence the height of building is obtained here. Hence prove that height of building is H tan alpha upon tan beta minus tan alpha. Now finally the chapter number 9 is completed. Whenever we meet in next session, we discuss our new chapter. new theory and new sums. If you have any query regarding the chapter number 9, some applications of trigonometry, please tick mark it very well.